नमस्कार विद्यार्थी मित्र, मी सचिन पाटील कॉम्पिटेटिव्ह पोटेन्शियल टू अचीव्ह सक्सेस या युट्यूब चॅनलमध्ये आपल्या सर्वांचं स्वागत करतो. MPSC आणि UPSC मध्ये ऑप्शनल सब्जेक्टचा विचार केला तर मॅथ्स हा ऑप्शनल सब्जेक्ट असा आहे जो तुम्हाला पैकीच्या पैकी मार्क देऊ शकतो. थोडासा अवघड आहे, परंतु आपल्या उत्तरांना कोणीही क्रिटिसाइज करू शकणार नाही. जर आपण ते परफेक्ट सोडवलेलं असेल तर पैकीच्या पैकी मार्क ते मिळण्याची जास्तीत जास्त संभावना आपल्याला बघायला मिळते. याच्यामध्ये पेपर 1 आणि पेपर 2 असे 2 पेपर आपल्याला बघायला मिळतात. पेपर 1 मध्ये 250 मार्क असतात. त्यापैकी एक असा टॉपिक आहे ऑर्डिनरी डिफरन्शियल इक्वेशन, ज्याच्यावरती आतापर्यंत 40 ते 50 मार्काचे क्वेश्चन्स विचारले गेलेले आहेत. सो हा टॉपिक 20% वेटेज पूर्णपणे पेपर 1 मध्ये ठेवतो. म्हणून हा खूप महत्त्वाचा आणि खूप इम्पॉर्टंट असा चॅप्टर आपल्याला बघायला मिळतो, ज्याच्यामध्ये आपण ऑर्डिनरी डिफरन्शियल इक्वेशनचं फॉर्म्युलेशन, फर्स्ट ऑर्डर फर्स्ट डिग्री डिफरन्शियल इक्वेशन काय असतं ते बघितलं, इंटिग्रेटिंग फॅक्टर्स म्हणजे काय असतात ते बघितलं. त्याच्यानंतर आपण फर्स्ट ऑर्डर बट डिग्री हायर दॅन 1 याच्यामध्ये आपण 4 प्रकार बघत होतो. पहिला प्रकार आपण बघितला सॉल्व्हेबल फॉर व्ही, दुसरा प्रकार बघितला सॉल्व्हेबल फॉर वाय, तिसरा प्रकार बघितला सॉल्व्हेबल फॉर एक्स, आणि आता आपण चौथा प्रकार बघणार आहोत. आणि जो मोस्ट इम्पॉर्टंट टॉपिक आहे, ज्याच्यावरती आपल्याला एक क्वेश्चन UPSC आणि MPSC मध्ये विचारला जातो, आणि तो म्हणजेच आपला आहे क्लारॉट्स इक्वेशन. तर क्लारॉट्स इक्वेशन आपल्याला काय असतं? फर्स्ट ऑर्डर the first order differential equation. बघा, फर्स्ट ऑर्डर डिफरन्शियल इक्वेशन y is equal to px plus f of p is called Claraut's equation. Claraut's equation where f of p is the function. हे आपल्याला एक बघायला मिळतं. फर्स्ट ऑर्डर डिफरन्शियल इक्वेशन y इज इक्वल टू पी एक्स प्लस एफ ऑफ पी, हे जे आहे या फॉर्मॅटमध्ये असणाऱ्या इक्वेशनला काय म्हणलं जातं? क्लारॉट्स इक्वेशन. दॅट मीन्स हिअर वी गेट द फंक्शन ऑफ पी. दॅट मीन्स this term is in the form of p. This term is in the form of p, and here px plus, that means you will get the y is equal to px plus f of p is the Claraut's equation. Then how to find out the general solution and singular solution related with the Claraut's equation. The general solution and singular solution. This is the most important point inside the Claraut's equation. For this purpose, we have to take the Claraut's equation and differentiate it with respect to x, and then you will get the we have y is equal to p x plus f of p is here, and first of all we differentiate with respect to x is here, and therefore you will get the dy by dx is equal to, here multiplication rule, we apply the multiplication rule. P is taken as it is, and derivative of x is equal to 1, plus x is taken as it is, and derivative of p is dp by dx is here. And then you are going with the f of p. First of all, we have to take the derivative of f of p is f dash p, and the derivative of p is dp divided by dx is here. Okay, then we know that about the dx, dy by dx is nothing but a p, and therefore p is equal to p plus x into dp divided by dx plus f dash p into dp divided by dx is here. Okay, and after that we're taking dp divided by dx is a common here, and transfer this p on other side. You will get the complete equation like that. Dp is taken as a common, dp by dx is taken as a common, and inside the bracket x plus f dash p is equal to p cancel to each other, and therefore you will get the 0 is here. And according to that equation, you will get dp divided by dx is equal to 0, or x plus f dash p is equal to 0. Okay, and we first of all carry out the case 1 related with this equation, and here it is equation number 1, and now case number 1. Case number 1 is what? Case number 1 is what? dp divided by dx is equal to 0. Then variable separable form is directly we are getting the integration. Integration is here. Dx is transferred to another side, then it becomes a 0, and therefore integration of this is nothing but a p is equal to c. C is the integration constant is there, and by putting this p is equal to c in equation 1, we get the general solution, and therefore put p is equal to c in 1, we get general solution. We get general solution is here. Okay, and according to that, you'll get the y is equal to cx plus f of c, and this is your general solution is there, and it is nothing but a combination of a number of straight line is here, and we get the general solution from that one. Then we are going with the case number 2. Case number 2 is here, and according to that case number 2, x is equal to x plus f dash p is equal to 0, and by using this equation and equation 1, we are eliminate p from the equation, and eliminate p from the equation, and we get equation without arbitrary constant, and uh, which is not obtained from the general solution, and therefore without any arbitrary constant and eliminating p, we will get the singular solution. Here. Okay, and this is your case number 2. According to that, you will get the singular solution of that one, and to find the general solution of that Claros equation, we just replace p by x in Claros form. Then you will get the general solution of that one, and general solution is y is equal to cx plus f of c is there. And for finding the singular solution related with that Claros equation, we just eliminate p by using x plus f dash p is equal to 0, and equation number 1 is there. We will get the equation which does not have any arbitrary constant and which is not obtained from the general solution. Then this equation is called as, or this solution is called as a singular solution is there. Okay, and therefore singular solution is an envelope of all the straight line family which is obtained from the y is equal to cx plus f dash c is there. Okay, and you get the extended form of the that what you can say Claros equation, and this extended form of Claros equation is nothing but a y is equal to x into g of p plus f of p is there, and y is equal to x into g of p plus f of p is there, and the solution of this equation is f of x comma p comma c is equal to 0, and which is nothing but a general solution of this extended Claros form is there. We are just going with an example related with that Claros equation and how to find out the general solution and Claros so singular solution related with the Claros equation is there. Okay, so we find out the general solution of that differential, general and single solution of that differential equation. y is equal to x minus a to p plus minus p square, and this equation is in the compare with y is equal to xp plus f of p, and therefore it is a function of p, and therefore here you will get the function of p, that means it is a p square, and here x is just replaced by x minus a is here, and therefore this is a Claraut's equation, and therefore we say that it is a Claraut's equation. So for finding the general solution of Claraut's equation, we just replace p by c, then we get y is equal to x minus a into c minus c square. This is general solution of that Claraut's equation. Now we want to find out the singular solution. And singular solution, it is the envelope of this general solution, and for this purpose we know that singular solution is envelope of general solution. So we find out the what you can say, we find out the singular solution by using the general solution. We just convert this, we get this general solution is in the form of a quadratic equation. For this purpose I'm just transferring these values on this side, and you will get the equation is nothing but a c square minus x minus a into c plus y is equal to 0 is there. Okay, and you will get the what you can say, okay, and we compare this equation with the quadratic equation. Compare with quadratic equation. And quadratic equation is ax square plus bx plus c is equal to 0, and we find out the here x is replaced by c, and therefore c square, it is nothing but x square, c, it is nothing but x, so that these are the coefficient related with that one, and therefore a is equal to 1, b is equal to minus x minus a, and c is equal to y is there. Okay, and according to that we go through the discriminant b square minus 4ac is equal to 0, and by using this equation we can find out the singular solution, because we know about that the singular solution is a c discriminant of quadratic equation in the c, and which is equal to 0. That means c discriminant is equal to 0, and for this purpose we have to find out the values of a, b, c in a quadratic equation of c, and therefore you will get the b is equal to this. That means you have to get into b square, that means x minus a square, because minus square is equal to plus, and then 4 into a is nothing but a 1 into c is equal to y is equal to 0, and therefore x minus a square minus 4y is equal to 0, and this is your singular solution. This is singular solution of Claraut's equation. Are you getting my point related with this one? We go through another example which is not in the Clarod's form, but we want to convert it. We are able to convert that equation in a Clarod's form. Then we have to find out the general solution and what you can say singular solution related with that Clarod's equation, which is reducible in a Clarod's equation, not actual Clarod equation is there. Okay, we want to find out the general solution, and the singular solution of that y is equal to 2px plus y square into p cube. Right now we see that this is not only a f of p, and therefore it is not a Clarod's equation, because according to the Clarod's equation form, y is equal to what? Px plus f of p is there. That means it is an equation, or this term is in the form of only p. It is a term of p, but here we see that this is a y square is there, and for this purpose it is not a Clarod's form. This is not Clarod's equation or form is there. So we want to convert this equation in a Clarod's equation. We multiply both side by y. What do you get? Y square is equal to 2pxy, or okay, 2pxy plus y cube into p cube is here. So we put capital Y is equal to y square. So first of all we have to find out the derivative of this with respect to x, and therefore dy by dx is equal to 2y into dy by dx is here, and so that you will get the dy by dx is nothing but a p, and therefore 2y into p is there. This 2 is transferred on another side. You will get the yp is equal to 1/2 dy by dx is here. Put dy by dx is equal to capital P is there, and you will get the value of this is nothing but a yp is equal to 1/2 capital P is there. So those values are put inside this equation. Let us consider this equation is 1, and using this value inside this equation, you will get the equation like that. What is it? It is nothing but the capital Y is equal to, here also you will get the yp, y into p, and y into p is equal to 1/2 p, so that this 2 is taken as it is into this x is also taken as it is. That means 2x is taken as it is, and this yp is replaced by 1/2 into p, 1/2 into p, and then plus y cube dot p cube, y cube into p cube, that means yp raised to 3, and therefore it is a p raised to 3 is here. P raised to it is a capital P, and so that p raised to 3. Okay, and then sorry, yp is equal to 1/2 p raised to 3 divided by 8 is here, and these two cancel. You will get the capital Y is equal to x into capital P plus y p raised to 3 divided by 8, and this equation is equation number 2. It is a Clarod's form. Clarod's form. Okay, this equation is in the form of Clarod's equation because we know that about y is equal to xp plus f of p. That means this function is only in terms of p, and therefore you will get the Clarod's form. And you want to find out the general solution, just replace p by c. We get we get general solution. And you will get capital Y is equal to small xc plus c cube divided by 8 is here. C cube divided by 8 is here, and this is your what you can say, and y is replaced by y square is here, and therefore you will get the y square is equal to xc plus c cube divided by 8. This is your general equation, general solution. Later to consider it is a equation number 3, and we know that the singular solution is an envelope of a general solution. So we find out the singular solution is envelope of general solution, so that partially differentiate it with respect to C. Okay, partially differentiate this equation with respect to C, you will get what? You will get y square. It is not a function of C, therefore directly answer is 0 is equal to x plus, because derivative of C is with respect to C is nothing but a 1, and then you will get the derivative of this 1 divided by 8 into 3c square. Okay, and then 0 is equal to x plus 3 divided by 8 into c square. X is transfer on other side, you will get the c square is equal to minus 8x divided by 3 is there, and putting this value of c square inside the equation number 3, put in 3, we get y square is as it is equal to xc plus, here 1 divided by 8 into c. I'm taking one c out from that c cube, and therefore only c square is there, and c square having this value, and putting this value is here 8x divided by 3. We cancel out the 8, and y square is equal to xc plus minus is there, 8 cancel to each other, xc divided by 3, and y square is equal to 1xc minus xc divided by 3, that means it is a 2xc divided by 3 is there. And to find out the value of c, it implies that 3 is divided, it is multiplied on other side, 2x is divide on other side, therefore you will get the c is equal to 3y square divided by 2x, and c is equal to 3y square divided by 2x placed in the equation number 4. This equation we have to consider equation number 4, and c is equal to 3y square divided by 2x placed inside the equation number 4. Putting in 4, we get final result. C square is nothing but a 3y square divided by 2x is equal to minus 8x divided by 3 is there, and transfer this value on other side, you will get the 3y square is equal to minus 16x square divided by 3. This 3 transfer on this side, you will get the 9y square is equal to minus 16x square. This also transfer on this side, 16x square plus 9y square is equal to 0. It does not contain any arbitrary constant, and therefore this equation is nothing but a singular solution of that differential equation, or this Clairaut's form equation. Are you getting my point? If your equation is not in the form of Clairaut equation, we adjust it, and according to adjustment we have to convert that equation in the Clairaut's form, and then we replace P by C, you will get the general solution. And we want to find out the general solution which is enveloped inside the general singular solution which is enveloped inside the general solution. We partially differentiate that equation and find out the value of C and place this value of C in equation. You will get the final result, and which is nothing but a what you can say 16x square plus 9y square is equal to 0, and this is your final solution of that differential equation is there. Are you getting my point related with that one? And this is a Claraut's equation. We have to find out the solution of that some general solution and singular solution related with it. Okay. जर हे तुम्हाला आवडलं असेल तर लाईक करा, शेअर करा आणि सबस्क्राईब करायला विसरू नका. थँक्यू. Sorry, little bit of mistake is here, and this mistake is nothing but what I am taking only C, but here you want to take the C square, and therefore squaring on this side you will get the final result. Sorry, and just rough it, and squaring on both sides you will get the 9y raised to 4 divided by 4x square is equal to minus 8x divided by 3. Then transfer the values, you will get the 9 into 3 27 y raised to 4 is equal to minus 32x cube, and then transfer this on this side, you will get the 32x cube plus 27y raised to 4 is equal to 0, and this is your final result. I am just taking the value of C is here, and which is not a correct one. For this purpose we just C square is there, and for this purpose C square, that means squaring on this side you will get the final result, which is a 32x cube plus 27y raised to 4 is equal to 0. Are you getting my point related with this? Okay. Like, share and subscribe this video so that I will give you very well information related with the mathematics as an option to UPSC and MPSC is there. Thank you.